Saturn, the ringed wonder, a planet that has fascinated astronomers and stargazers for centuries. Saturn is a gas giant made mostly of hydrogen and helium, giving it a unique appearance. It's the sixth planet from the Sun, situated between Jupiter and Uranus. Saturn is known for its beautiful rings, a complex system of multiple rings and gaps. These rings are made up of ice and rock, reflecting sunlight and visible from Earth. One theory is that the rings are pieces of a moon torn apart by Saturn's immense gravitational forces. Saturn's rings are composed of countless individual particles, each orbiting Saturn independently. Imagine a giant racetrack in space with particles orbiting Saturn like tiny cars, creating a mesmerizing celestial ballet. Cosmic debris, the building blocks of rings. Saturn's rings are one of the most fascinating features in our solar system. What are these particles made of? This question has intrigued scientists for decades. Most of them are ice, like the ice we have on Earth, but much colder. These icy particles reflect sunlight, giving the rings their bright appearance. Some are made of rock, like the rocks we find on mountains. These rocky particles add to the diversity and complexity of the rings. These ice and rock particles are remnants of a time long ago. They are ancient, dating back to the formation of the solar system. They are like cosmic leftovers from the early days of our solar system. Studying these particles helps us understand the conditions that existed billions of years ago. By studying them, we can learn about how planets formed billions of years ago. This research provides valuable insights into the processes that shaped our solar system. The rings are also surprisingly thin. Despite their vast width, they are incredibly slender. Even though they are thousands of kilometers wide, they are only a few kilometers thick. This thinness is one of the most surprising aspects of Saturn's rings. Imagine a sheet of paper as wide as a football field. That's how thin Saturn's rings are compared to their width. This comparison helps us grasp the scale of these magnificent structures. The rings are constantly moving. This motion is a dynamic dance of particles. The particles are all orbiting Saturn at different speeds. Each particle follows its own path, creating a complex and ever-changing pattern. It's like a giant cosmic racetrack with particles zooming around Saturn like race cars. This constant motion is a reminder of the dynamic nature of our universe. Gravity's dance shaping the rings. Saturn's rings are not just a random collection of particles, they are organized into different bands and gaps. These patterns are created by the gravity of Saturn's moons. Imagine a shepherd herding sheep. The shepherd keeps the sheep together and guides them. Saturn's moons act like shepherds to the ring particles, keeping them in line and creating gaps between the rings. Some gaps in the rings are caused by resonances with Saturn's moons. This means that the gravity of a moon pulls on the ring particles in a rhythmic way, creating a gap. The rings also have spokes, which are temporary features that appear as bright or dark streaks. Scientists believe these spokes are caused by the interaction of Saturn's magnetic field with the ring particles. It's like a giant magnet moving through iron filings, creating patterns. Section 4. A ring system in motion. Saturn's rings are a dynamic and ever-changing system constantly in motion. They are constantly being bombarded by meteoroids and comets, adding new material to the rings. Imagine a rain of dust falling gently on the rings. This cosmic rain is made up of tiny particles from space, constantly replenishing the rings. Saturn's rings are also slowly losing material over time. The gravity of Saturn is pulling some of the ring particles inwards, where they eventually burn up in the planet's atmosphere. The rings also interact with Saturn's magnetic field, creating electric currents and radio waves. These interactions can be detected by spacecraft studying Saturn, providing valuable clues about the composition and structure of the rings. Section 5. A symphony of ice and rock. The rings are not uniform in color. They have different shades of gray, brown, and even a hint of pink. These colors are caused by the different compositions of the ring particles. Some parts of the rings are made mostly of pure water ice, giving them a brighter appearance. Other parts contain more rocky material, making them appear darker. The size of the particles also affects their color. Smaller particles tend to scatter more blue light, while larger particles scatter more red light. This is similar to how the sky appears blue because air molecules scatter more blue light than other colors. The constant collisions between particles also play a role in the ring's colors. These collisions create dust, which can coat the ice particles and change their appearance. Section 6. The ever-changing rings. Saturn's rings are not static. They are dynamic and ever-changing, constantly influenced by a variety of factors. They change over time due to various factors including the gravitational influence of Saturn's moons and the influx of new material from space. The gravitational pull from Saturn's numerous moons can cause the rings to shift and alter their structure. One of the most dramatic changes in the rings' appearance is their tilt. This tilt can make the rings look vastly different depending on the angle from which they are viewed. As Saturn orbits the Sun, the angle at which we view the rings changes. This orbital movement causes the rings to present different faces to us over time. Every 15 years or so, the rings appear edge-on from Earth, making them almost invisible. This phenomenon occurs because of the way Saturn's orbit aligns with our line of sight. The rings also experience seasonal changes. Just like Earth, Saturn has seasons, and these seasons can affect the rings in various ways. As Saturn's seasons change, the amount of sunlight falling on the rings varies. This variation in sunlight can cause changes in the ring's appearance and temperature. This can affect the temperature of the rings and the distribution of material within them. Warmer temperatures can cause some materials to become more active, while cooler temperatures can cause them to settle. In addition to these gradual changes, the rings can also be affected by more sudden events, such as the impact of a comet or a large meteoroid. These impacts can introduce new material into the rings and alter their structure. These impacts can create ripples and waves in the rings that can persist for years. The resulting disturbances can provide valuable information about the composition and behavior of the rings. Section 7. Mysteries yet to unfold. Despite decades of study, Saturn's rings still hold many mysteries. Scientists are still trying to understand exactly how the rings formed and how they have evolved over time. One of the biggest mysteries is the age of the rings. Some scientists believe the rings are ancient, perhaps as old as Saturn itself. Others think they are much younger, possibly formed from a recent catastrophic event. Another mystery is the presence of spokes in the rings. While scientists believe they are caused by Saturn's magnetic field, the exact mechanism that creates them is still not fully understood. The study of Saturn's rings is a journey of discovery. With each new observation and mission, we learn more about these magnificent structures and their place in the grand tapestry of our solar system. Thanks for watching. Don't forget to like, comment, and subscribe.